So you want to be a rock star? Well, then get your hands on a Casio CZ101 digital synthesizer with its multi-timbral MIDI capabilities and dual line of Casio PD sound generators. This isn't just a synthesizer. Oh, it's a rocker launcher. Casio digital synthesizers with Casio PD sound. So easy to play, they're rocker launchers.
Alright, recently I went on the internet with the express purpose of finding a broken synth and seeing if I could fix it. Now this one in particular, the person that sold it to me has already had a go at fixing it, so this could actually prove quite challenging, but I think I have a hunch of what might be wrong with it. So let's dive into the classic unboxing experience. So I've got my knife, a very nice knife it is, very nice. And let's cut into it. This package seems to be quite well packaged. It may take me a little while. Oh yes, I feel the satisfaction of this unboxing experience. What is this mystery synth? Knowing me, it's not likely to be anything good. It's a mini rocker launcher. So this is a Casio CZ, Casio CZ series. These keyboards were good enough for plugins to be made out of them, modelled after them. This is one of the smaller ones, clearly. And we've got what, 4 octaves on sort of a miniature keyboard. It's got guitar strap holders on either end, so you can look like Edgar Winter.
Okay, I wrote a song to feature the synthesizer called Frankenstein.
Volume with the knob missing, a bit dirty, big old scratch there. Missing battery cover, signs of some leakiness. It's got MIDI on it and cartridge slot. Didn't know it had that. Probably for loading in some cool sounds. Phones line out, DC jack. Now this is what I reckon might be the actual problem with this. Yeah, so the automatic power off switch is missing. And I reckon that's kind of key to all of this. So yeah, the mission is to fix this and see if I can sell it for more than I bought it for. Can we flip it for a profit? Yeah, so if we can get this thing working, hopefully I can like cruise around space on it like the guy in the advert. That'd be fun. Okay, small disclaimer, I'm no expert when it comes to electronics, and there is some information in this video which is kind of an educated guess. Diving into this repair, there is lots of things which seem quite complex with the circuit design, particularly with the power supply. Some of the features here might be kind of common in other stuff Casio made, like calculators and other things with like auto power on and off, but you don't see that sort of thing in your average Roland synth of the same era. Perhaps Casio are bringing some of their own flavour to the mix. Which brings me to today's sponsor, Balls Cream, the premium product for pocket billiard players. Okay, yeah. I'm not going there, even though we sort of just did. Yeah, obviously my channel is way too insignificant for sponsorship right now. However, if you want to help me out, you can smash the subscribe button, you can smash the like button. Unlike some of the buttons on this Casio CZ101, they actually work, and it will help me out for sure. So, yeah, it's a learning experience for me too. If you are an expert and care to point out some of my dim-wittery in the comments, please be my guest. If you're no expert, comments all good too. Leave a comment. Okay, so I've taken the case off the back of this Casio, which wasn't very difficult. There was literally like 2 screws holding it all together. And yeah, on the eBay listing when I bought this, the seller said they'd attempted to repair the power jack, but didn't get too far with that. So yeah, on closer inspection, you can see that he's soldered something in, but it's not making any kind of electrical connection to anything, as the pads on the circuit board are missing. Hopefully this is just kind of an easy fix and that's all that needs to be done. Also I can see the automatic power off selector switch here, which is broken. It's still intact. I can move it with a screwdriver. It's incredibly rusty though. Looking at everything else in here, it doesn't look too bad. It doesn't look like it's been underwater or anything like that, which is good. Construction is not that dissimilar to the Casio MT41, which was intended for the sort of the home market. Got all these kind of ribbon cables here that are just hard soldered to each circuit board, so if I wanted to take this all apart, then it all has to come out in one kind of messy lump. Interesting thing, I think this must be like a reset switch that you poke a screwdriver through the circuit board to activate that. The back case here, the battery compartment wires have been sort of clipped out. These aren't connected for whatever reason. I guess it just makes it easier to take it apart and work on it. I think first steps, I'm going to continue kind of scraping away the protective coating on these traces, make a proper electrical connection on that power jack. Probably before that I might sort of poke around with a multimeter and see if there's anything that's kind of shorted out. Incidentally, this brown paper that's screwed to the underside of the case, I reckon this is some kind of RF shielding. You can see sort of the remnants of some foil on there, but as it is now, that's just a pointless bit of paper. But yeah, possible more signs that this has been exposed to a load of liquid at some point. This circuit board here is very clean though. It's only really this first board which has some kind of gacky stuff on it. Okay, so I'm just checking for any shorts before I sort this power jack out and power it up. I'm just gonna check across the positive and negative of the incoming power. As you can see, that's just saying open lead, so that's all good. Check out some of the voltage regulators as well, see if any of those are shorted across any of the pins. This one here all looks good, really. Nothing to worry about. Yeah, so I think we're all good. We put some power in it and hopefully nothing starts smoking. Okay, so there's a helicopter flying around up above. I don't know if you can hear that. Get to the chopper! What I've done is I've scraped back part of the track here and put a bit of solder on there, and I'm now gonna just take a bit of a lead from this resistor to bridge the gap there. So let's put that in. Cool. It's not the most elegant of repairs, but you know, hopefully we'll be able to see if it's working or not. We'll just do the same for this other connection. So this middle connection, that is a switch which will, if there's batteries in it, will take out the battery power when you plug a DC jack in. So we don't need to worry about that too much right now. Again, not super elegant, but you know, we can go back in and tidy it up, or not. Throw some power in it and see if it works. All right, moment of truth. Let's plug in the power jack. It's in, power on. There was sort of something, and then there wasn't. Okay, so when the power switch is off, there is always power coming in to this first regulator, the VBR regulator, and now that generates around 4.5 volts, which it sends over to the logic part of the power supply. And in order for the main 5-volt regulator to turn on in the power supply. This part of the logic circuit needs to achieve a certain state of logic. However, there is another little part to this circuit called the power down detection circuit, which is over on the other circuit board, and that was essentially the thing that's kind of causing the problem here. It's not allowing this circuit to turn on, but there's lots of other stuff going on here. It sort of receives like reset signals and other power detection signals from the main board, from the main sort of CPU, like I've just circled here. So yeah, in order for the main regulator to turn on, essentially all those conditions need to be met in logic. You can see here we've got lots of AND gates and NOR gates and inverters and all sorts of logic stuff. Yeah, I can't really pretend that I really fully understand what's going on there. But anyway, when the various conditions are met in the logic circuit and it's all happy, pin 11 on this chip, which is a NOR gate, goes high, which turns on transistor T5. With T5 on, T2 has a path to ground from its base. It's a PNP transistor, so it kind of works the opposite way around, if you like. With T2 active, current can then flow through T3 and T4, which T4 is the main 5-volt regulator. So if any of those transistors are bad, then there's no 5 volts, and that's the end of it. This may seem a little overcomplex, and it sort of is really. I think Casio did this so the CPU has some control over the power supply. It can turn it off, and there's other circuits that can also turn off the power. And I think Casio did this to preserve battery life mainly. So for example, you've got like an auto power off function which powers down the synth after a certain period of inactivity. And also there's a low power detection, so your batteries don't go completely flat. Normally in other synths you might see in this sort of area, there's like a little 3-volt lithium battery which is there to kind of keep some power in the memory chips, and so you can store your presets. The Casio doesn't actually have that. It's actually uses the batteries that you chuck in the back, the big D cells, which you can also power the synth from. We'll actually also use those to store preset memory. So yeah, you've got these kind of functions in the power supply that stop those batteries from getting completely drained, so that, you know, even in a low power state, the keyboard might start behaving a bit erratically if the CPU is not getting enough power. But also you're not going to lose any presets or any settings that you've got stored in there. Yeah, but either way, it's pretty complicated. Alright, so I've got the Casio to power on. We're actually seeing some life in it, which is good. Most of the buttons seem to work, apart from these ones for DC01. Can't get anything out of those. Yeah, I've plugged some headphones in, and not a lot of sound comes out. I wiggle the jack around, I can hear a faint bit of noise. It's doing something, so that's all a good sign. So simply all I did, because I wanted to check that the main regulators were all working properly, was I just took a little jumper lead and I went to the emitter of T11, which is sort of the output, if you like, of this first regulator that's always turned on. And then I just touched it, shut up you, then I just touched it to the base of T5, which allowed this main regulator to turn on. Then I was seeing 5 volts there, so I knew that the main regulator was working, and the fault was lying within this sort of logic stuff. You can see the CPUs and stuff there. There it is, the power down detection circuit. So essentially we've got like an op amp or a comparator there that is looking for a certain voltage threshold, which is set by this little preset trimmer here. Essentially what this does is when the voltage drops too low, it turns off T1, and that in turn sends a signal over to all that logic on the other board and turns off the power supply effectively. So all I did really was to jack that little preset all the way in one direction so it never exceeds that threshold. You can see on the circuit board here, I grab the headphone jack and wiggle it. These solder joints are crappy. See, they're just wiggling about there. Also, the power light has started flashing, so I don't exactly know what that means. It's probably because I've completely bodged the power supply.
at the graveyard, low definition. Turn the flags down. Fiery visions, burning beauty.
Flamethrowers gone rise to image.
Inner monologues from a different dimension.
Up like a rhetoric, hyperbole.
Face the wisdom.
Alright, so I'm going to try and get those buttons working. There's like a row of buttons that was not working. Fortunately, that circuit board is underneath the power supply, so it's kind of quite easy to get to. The main board here is, yeah, it's got hundreds of cables and things coming off it, so if I can kind of leave that mostly in place, then that's all good. Oh no, oh no. Yeah, this is all connected to that. It is all going to have to come out. Well, I mean, this is all a bit boring really, isn't it? Unscrewing stuff. Alright, so yeah, this big mess here is the guts of the Casio. I've had to pull it all out to really try and fix the problem that we're having with these buttons. So it's this row of buttons here along the bottom. You can see each button has an LED associated with it, so you can tell when it's active or not. And it's just these little silicon membrane pushy things, pads on the circuit board. But anyway, yeah, it's that row that's dead. Essentially these buttons are kind of multiplexed, so they have common pins. One side of each button relates to the top row of buttons, and we all know those are working, so it's the other side that they will connect to, which is one common pin. It's this row of buttons here, KC14. You'll see that they're kind of commoned together through a diode. The most likely cause really is these ribbon cables that come off the board. There's probably a break in one of them. Alright, got the meter out, set to continuity, and I'm just looking for breaks in the traces on the circuit board or wires that have become disconnected on a ribbon cable. So I know that cluster of buttons that I was just talking about a moment ago has kind of gone dead. I know it's the common connection comes to here on the circuit board. I just kind of looked at it to figure that out, and then I had to look at the schematic again to see which of these ribbon cables it goes to. Each ribbon cable has a couple of letters associated with it. For example, that one is JF, and it comes over to this one, which is JC, I think. I know that goes to pin number 10 or connection number 10 on the ribbon cable. So if I get continuity here, then I know that the trace and the whole circuit board over to this ribbon cable and off it is all good. That is the wrong connection there. It's actually up here and pin 10. So yeah, there we go. That is all good. From pin 10 it just goes straight over to this ribbon cable on pin 3. And you can see that's all good. When I got to the other side of this ribbon cable over on this circuit board and found that there was no continuity, so essentially there was a break in this ribbon cable. See that there is a broken connection. Put the camera nicely in the way. Hopefully that's done it. Alright, moment of truth. I've actually already tested it. I know it already works. Okay, so this was the working row. Let's put this little silicon membrane button here. I should be able to see that. It's quite bright in here. Let's turn that on and off. And this row down here was not working before, but now that works. Yes, it's quite an insanely annoying thing to put back together. Everything just kind of gets in the way of everything else, and yeah, I'm getting there though. Right, so I got this Casio all put back together and it's all basically working. The headphone output's a little bit noisy, but the line output's fine. I think that's kind of normal with this. There is a few issues. I mean, I've got all these buttons working, but for example, on this one, the LED does not light up, but the button is functional. You can see I'm pressing it here. And that's the same on this one, same on this one, oh, no, that one, this one, and this button too. So yeah, most likely what's happened is I've damaged one of the ribbon cables, putting it all back together. It's really tricky putting this thing together and taking it apart without breaking one of those delicate ribbon cables. The reason why I'm pretty sure it's that is because basically these two rows of buttons, they share a common pin. They're kind of multiplexed. I'm not going to get into multiplexing too much in this episode, but basically what that is since the mid-80s or maybe earlier, synths normally have some kind of microprocessor to control it. On the front panel there may be lots of buttons to control parameters and different functions, but the problem is a microcontroller or CPU, etc. have a limited number of IOs, ins and outs, maybe just 8 of them, and if you were to connect each one of those IOs to a button, you're not really going to get very far. And not forgetting that the entire keyboard also needs to communicate with the processor, so in the case of the Casio that's 49 keys. Also not forgetting that there's all these sort of outputs such as status LEDs, the LCD display, MIDI ports and so on. They all need to use those IOs. So where resources are scarce and to keep wiring simple and not really bulky, this is where you use a keyboard matrix or switching matrix. Also multiplexing and demultiplexing is incorporated in all this. With a keyboard or keypad matrix, if you imagine, for example, 16 buttons arranged in like a 4x4 grid, one side of each switch in a given row is connected together, and then the other side is connected together in each column. So each column and row is scanned many times a second to detect a button press. A variety of logic chips can perform that task, or a dedicated controller. The output might look something like a 4-bit binary code, setting 4 output pins either on or off. 4-bit binary would represent 16 numbers, which would correspond to our 16 buttons, and the whole thing of course can be scaled up. To streamline things further, we can use a principle known as multiplexing. A multiplexer circuit or IC can connect multiple sources to a single input. One technique for this is to switch between the different paths over timed intervals and to channel that information to, for example, a single I/O on our CPU. The multiplex will then be in sync with the CPU, so the CPU knows where the data is coming from, effectively. Again, this switching happens many times a second, so easily fast enough to respond seamlessly to a human ape-like person pushing buttons. The same principle works in reverse, demultiplexing or demuxing, and that can control LCD displays or arrays of LEDs from just a few wires. So yeah, this is more or less the sort of thing that's going on inside the Casio. It's a bit different, but fundamentally the same. I'm glossing over it slightly to avoid a complete engineering of the CZ101 video. Anyway, all that to say, I probably broke a few wires on this flimsy ribbon cable. But anyway, the buttons all function, it's just that the LED doesn't light up. And weirdly, the power button, the power light and the power button doesn't light up anymore. I'm not really sure what that is. It's probably a similar thing. I literally have resoldered the cables going to the power button about 5 times now. They're really, yeah, you look at them wrong, they just snap off. It's that kind of thing. But yeah, it works, it makes sound. It is what it is. It's not the best made keyboard ever, so the plastic is very brittle. It breaks. There's only a couple of screw holes that will hold it all together now. That's about it. Okay, so I've had a little poke around, and you can see on this ribbon cable there's a couple of bad connections right in the end. These cables relate to the LEDs on the schematic. The power light that's gone off, that's just bad solder joint there, so I just need to touch that up. Then the master tune, which also wasn't working, should be able to see that broken trace in the end there, just there. So yeah, I'm just going to fix those, same way I did everything else, and hopefully put this thing back together for the last time. Repair, and repair. Right, flashy power light is back. And yeah, all of these are working now. Ooh. So yeah, that was kind of successful. Still cannot get these to do anything, so I'm just not sure about that. So I think part of the problem I've been having with the Casio is this power supply that I've been using. It's a 9-volt adapter that I've just sort of modified. I've changed the polarity on it because the Casio uses center negative. This is supposedly a 9-volt adapter, and it runs off an input voltage of 230 volts. However, when I plug it in, test the voltage on this, 16.5 volts out of that. That's kind of to be expected because this is it's not like a modern switching power supply. This is sort of an old school big transformer. In fact, it's probably only got bridge rectifier in it and then a capacitor. There's probably not any kind of regulator going on in it. Why don't we open it up and take a look? Okay, so we'll pull that open. Yeah, as you can see inside, that's all it is. It's just transformer, bridge rectifier, smoothing capacitor. It's probably not the most stable of power supplies. Now, although now when I'm testing at the moment, we're getting whatever it was, 16.5 volts. That's kind of normal. As soon as you put like a load on that, that voltage should drop. LED lamp here as a load. There we go. There we go, 16.5 volts. Now this lamp's probably only something like 2 watts or 4 watts. So it's not a huge load. Ooh, I can't actually see that, can you? So it's dropping to 11.5. It'll drop in about 5 volts as soon as we put a load on it. Now bear in mind, this power supply is meant to run off 230 volts, and if we go to the meter, we can actually see what kind of voltage is coming into the house. And we've got voltage up here, 245 volts. So again, we've got 15 more volts coming in on the input. So we've kind of gone to the opposite end of the spectrum here. We've got a switching power supply here, so taking mains voltage in, and it's spitting out 12 volts into this little buck boost converter here. Tune that down to 9 volts for the Casio. Pretty much on the nose, 9 volts there. And this should be super stable because it's effectively regulated, then further regulated. So if I power this on now, no flashing power light, rock solid. There's a couple of other adjustments that could be made inside for voltages, so I think we'll sort of go through and check those now. Sometimes for this kind of stuff you need a good quality power supply. Okay, so there's a couple of voltages to adjust inside the Casio. The first one is over here on the main power board, and you want to be seeing sort of 4.3 volts when you're measuring the voltage. When you're measuring the voltage from the emitter of T11, transistor 11, you just adjust this preset potentiometer, and yeah, like I say, you want to be seeing 4.3 volts, and you want the power button to be turned off when you're measuring the voltage on this one. So if we plug it in, 2.7. 4.34. Right, I'm happy with that. So the next voltage to measure, setting to make, is over on the main circuit board, and it's the VR4 preset potentiometer number 4. Yeah, this one here. And you want to take the measurement from this op amp, pins 5 and 7, and you want the potential difference between those pins to be as close to nothing as possible. You also want the power to be switched on when measuring this voltage. Power switched on, nothing playing. And 3.6 millivolts. I'd say that's fine to leave that alone. Okay, and the last adjustment is just VR1. This is the power down detection circuit. VR1, just here. It's partly why I have this extremely over elaborate power supply that I put together, is that I can actually adjust the voltage on this. You want to be putting 6.3 volts into the Casio, and then you set VR1 on the main board to the point that the power turns off. Okay, so we're currently pretty accurately on 9 volts here. So let's adjust this down to 6.3 volts. So obviously if you've got like a lab bench power supply, you can obviously use that. Probably a hell of a lot less fiddly than this. Yeah, close enough. Let's go with that. So I'm going to plug it in. I'm going to turn the power on. The power light will probably flash for a bit and then it will turn off, hopefully, if it's set correctly. So let's give that a go. Plug it in. There we go. See the power light's flashing and it should turn off in a second. Okay, so that's not going off. Maybe it does need a small adjustment. There we go. That should be set. Alright, so I'll just adjust this again, so we're back onto 9 volts. Okay, here goes. Plug that in. Power on. No flashing light. All good. So really, that only leaves one thing left to do with this, and that is to fit a 9 volt battery. Just like a square guitar pedal type battery. Oh, so the other thing I kind of just worked out or read about is these master tune buttons do actually work. It's just when you use them, it doesn't display anything on the display, but it is actually shifting the tuning. It just doesn't show anything on the LCD here. These two diodes right here, they need to come out. They basically keep the batteries separated from the DC jack. And so, yeah, we're going to take those out, replace them because they're short-circuited. And instead of installing the old big chunky D cells in the back, we're going to fit a 9 volt battery. And that's just there to keep the memory settings in place when you turn the power off. So we've got this 9 volt battery clip, attached some wires that we just need to reattach to the original or existing battery points on the power supply. So it's pretty straightforward. This white one is positive. I'm just going to the positive there. There we go. Right, so I'm missing the battery cover for this. What I've got is some sticky back Velcro pieces. Put one on the battery, the other inside, and that should hold it all in place. Whoa, that is sticky. That can just go down on there. Put that on the side of there probably. So yeah, as this battery's not actually powering the keyboard, it's just keeping the memory powered. It should last forever, really, or pretty damn long time. Alright, so what did the repair cost?
Alright, okay, now we're in the quiet, safe room where none of the people whose stuff I stole can get to us. Now let's look at all the stuff we got.
We got some diodes.
That's 8 rapples.
We got some wire.
That's 6.5 rapples.
We got a 9 volt battery and a clip.
15.5 rapples.
So the repair didn't really cost anything. It was just bits I had lying around, and you know, if you were to buy those things, I don't know, £3. I bought the broken Casio CZ101 for £80, I think. So yeah, it shouldn't be difficult to sell it for more than that, really. Looking on eBay, the typical sort of price they go for is around £200 when they're working. However, there probably is a couple of other things to fix on the Casio, but you know, we'll get into that next episode. So I think it's about time to plug the rocker launcher in, take it for a spin, See how it sounds. Starting on the first preset. The keyboard is horrible, and also doesn't work too well. There you go, brass preset, pretty standard sounding. But as soon as you start editing some things, you can really kind of change the sound. Just start messing around with the waveforms on the DCO. Or we can kind of detune that a little bit. All starts to sound a bit more interesting. Mess around with the pitch as well on the envelope. Turn the rate right the way down. Yeah. Vibrato. Get rid of that envelope. This button over here can turn the vibrato on and off. So, what do some of the other presets sound like? Right, I'm going to wrap it up here for this episode. Next episode, we're going to look at some sounds, making some sounds, a bit more history, how it relates to Yamaha's DX7 FM synthesis and that sort of thing, and what Casio's phase distortion synthesis is all about. I was going to put it in this episode, but it's already starting to get a bit long. So, you know, thanks for watching and sticking around. Hopefully see you in the next one. Head over to ballscream.com now and use my checkout code BALLS2000 for a limited time discount of 50% on all Balls Cream products. And don't forget to tell them who sent you.